Hello, my awesome audience. I am back again. My name is Helen. It's really a pleasure to have you once again. Thank you so much if you're coming back to my channel. And if this is your first time, I really appreciate you. So in today's video, we'll be deploying an Nginx Ingress Controller to AWS EKS. Alright, so how this flow will be today is that I'm just gonna briefly touch on explaining how the traffic flow is, explaining what you're seeing on your screen right now. I also like to briefly explain some services we'll be making use of so that it doesn't sound strange once we get into the hands-on section. I will make it so brief because the focus is on the hands-on. Alright, this video will be so interesting. Ensure you watch it to the end because this knowledge is actually very important that you have it as a DevOps engineer, as a solutions architect, as a developer, everyone that uses Kubernetes. This knowledge is very it will be very helpful to you. All right, so you know how traffic is being executed when it comes to routing, efficient routing in Kubernetes, as well as saving costs for your organization. Please, if you are yet to subscribe, kindly subscribe to this channel. Click on the notification bell so you don't get to miss out on my subsequent videos. Also, drop me a thumbs up as an encouragement to keep producing quality videos for you guys. If you are ready, I am ready, and we can get started. So in Kubernetes, you know we have types of services, like we have commonly used services, okay? And I'm just gonna briefly touch on them. So the first one is cluster IP. And what is a cluster IP service in Kubernetes? It is actually a default service type in Kubernetes, and it provides a stable internal IP address for accessing your pods within the same cluster. This will actually ensure that you have the security you need, because it will basically limit access to only authorized users within the cluster. And we have the second one called Node Pod Service. What is this all about? This service is actually used when you want to expose your node externally. You want traffic to be traffic to be routed externally into your cluster. Okay, so first of all, this service exposes your application by opening a static port on each node in your cluster. All right, so that means, say let's assume you have just node A in your cluster. It will expose your application running in your node on a static port, so that external clients can actually reach you on that port. All right, and the second thing this does is that it allows external traffic basically, to reach your service through any node IP address and the static port. You use this node port service in a case where you need to access your application externally, okay, by specifying a specific port number, and the traffic will basically be routed to your service. So that is node port. And then we come to a load balancer type of service, which this load balancer type is actually what we'll be making use of together with our Ingress controller today. What is it all about? A load balancer service is a way to expose your application to the outside world. It is actually similar to node port service, because both node port and load balancer is a way to actually expose your application externally, so that external clients or users can actually access your application running in your cluster. Yeah, they're similar. However, a load balancer service also creates a cloud load balancer for you in your cloud provider, or it doesn't matter the cloud provider you're using, be it AWS, GCP, or Azure. It will just provision a load balancer for you, and it assigns it a public IP address. And don't worry, we'll make use of this load balancer service, and you'll see it while we are making use of an Ingress controller. This is an Ingress controller. Just as we've talked about node port and load balancer services in a cluster, and these are suitable for external access to your services or your application, they have limitations. Okay, they have limitations, and they can't really be used when it comes to managing more complex routing and handling multiple services. That is why we are going for Ingress controller. Okay, in Kubernetes, an Ingress controller is very crucial for efficient management of external network traffic. All right, so this ingress controller basically offers us a more resource efficient and scalable solution for providing a single entry point for external traffic. Ingress controller will give us a single point for our external traffic. All right, imagine when you have multiple services in your Kubernetes cluster. You don't need to say provision load balancer for each of those services for you to expose each of your service or your application. You don't need to be spinning up load balancer for that. Number one, is very costly. Secondly, it is not really that efficient when it comes to managing complex routing and all that. It will be more complex before you before you think of it, and that is not so efficient. That is why we are deploying an ingress controller today to help us in efficient routing system in our cluster and also to reduce the cost. For the various ingress controllers, basically, yeah, we have different type of ingress controllers, but we'll be talking about Nginx Ingress Controller. Yeah, we are using Nginx Ingress Controller, and this is basically an open source Kubernetes ingress controller built around Nginx. Okay, and you know Nginx is a popular web server and a reverse proxy server. Okay, so this Nginx Ingress Controller is basically designed to manage external access to services within a Kubernetes cluster. All right, Nginx Ingress Controller acts as a traffic manager, routing external requests, usually HTTP or HTTPS, to the appropriate services running within your cluster. So don't worry, we'll see how everything plays out practically very soon. One thing with this Nginx Ingress Controller is that it enables advanced HTTP routing, TLS termination, intelligent load balancing, and centralized management of routing rows. And I really like that. Okay, so you are not running around trying to see which services, which application is exposed with what service and all that. Okay, so this Nginx Ingress Controller will help to it reduces operational costs, yeah, but it also simplifies SSL certificate management, and it ensures consistent security configurations. As controllers are the preferred choice when it comes to streamlining traffic management within a Kubernetes cluster. And now let's explore this architecture. This is basically how the flow will be, and it will be a pleasure to see you really understand this at the end of this tutorial, how the traffic flows right from the user to the pod. Okay, so let's start with the user right here. This user could be a client, it could be an application that is trying to send an HTTP request. Okay, it could be a mobile application, it could be someone from his or her browser, or basically any client that wants to interact with your application. And when such person or an application sends a request, such request will be routed to an ingress managed load balancer. And what is this all about? This load balancer will be the one that will be provisioned automatically in AWS. Okay, so this will be provisioned automatically in AWS, and because we'll be deploying an ingress controller in our Kubernetes cluster, it will provision this load balancer automatically in AWS. So when a user send a traffic, it will hit the ingress managed load balancer here in AWS. And what is the work of this one? So the work of this ingress managed load balancer will be to send it over to the ingress controller in our cluster. Okay, so the ingress load balancer will just act as the entry point for your cluster. This is the entry point, so it will forward it to the ingress controller. So basically, ingress controller is responsible for managing and configuring the routing rules based on the ingress resource we've defined. So this cannot just go ahead to forward traffic further if it doesn't see any ingress resource to use. All right, so we'll be making use of an ingress resource. This is basically where we'll define our how we want our incoming requests to be handled. Okay, ingress resource contain rules for routing traffic to the appropriate service. Okay, it contains rules for routing traffic to the appropriate service based on the host names and paths. Okay, so over here we'll be specifying the host name, the path, and everything. Don't worry, you see how it's done practically. So once it comes from Ingress Controller, it will use the rule we have here to reach the appropriate service. Now it is the function of the service to locate the pods. Okay, you know these pods will be running our application, so the service will forward the traffic to the pod. Once the traffic is routed to the target port, then obviously your application will be reached, and the request will be processed, and it will be forwarded back. It will be sent back through the same path. It will be sent back to the same path to the client, and the client or the user over here will receive whatever he or she has requested. Okay, so this flow basically demonstrates how Ingress controllers facilitate the routing of external traffic to specific services and pods within your AWS EKS cluster, allowing for efficient and flexible management of incoming requests. Okay, so we can actually get started, and I'm already in my EKS cluster. Okay, so before we start deploying our Ingress, we need to actually deploy an application first. Okay, so I just have a very simple application we can use for this. Okay, so I already have my image here in the Docker Hub. It's actually public. All right, so I'll be making use of this. Feel free to also use your own image. Okay, so although I've already copied this, so will be adding this in our deployment manifest file to just deploy this application first. So I have my deployment manifest file here, and you can also copy that from the the Kubernetes documentation over here. So you can just type deployment, press enter, click on deployment, and you'll have the manifest file over here. Okay, so that's what I'm using. So coming over here, before the deployment, I want us to create a namespace specifically for this application. So I'll just type kubectl create. This I'm using alias. Okay, so I don't want to be typing kubectl or info. So kubectl create namespace, which is ns, and I would like to name this app space. And the namespace has been created. Kubectl get namespace, and you see our app space. Now we can go ahead to carry on with the deployment. So let me use vim up. Let me name this file app.yaml, and here I'll be pasting this deployment manifest. Okay, I need to copy that again. Alright, so this deployment manifest file will basically, the name here is app deployment, the label of our deployment is app nginx, and it will be having 2 replicas of the pod running. Okay, this is the template for the pod. This template will be used to provision our pod. The label will be app nginx, and the match label is also app nginx. The container here contains the name of our container. Okay, and we can still leave it as nginx. This is the image I just showed you in my Docker Hub account. So this is the image we'll be using, and this is the container port. So we are good to go. Before we leave here, we have to define the app space, which is our namespace. So I'll just type it here, app space. Right, so that this will be deployed in our namespace called app space. All right, so I'll just save this, and then let's deploy this application. So kubectl create -f app.yaml, and this has been deployed. Let's confirm that. App space, and this is running. So let's see the pod. Okay, yeah, They are running. So since we've gotten this up and running, we need to expose our application so that it can be accessed externally. All right, and I would like us to make use of a load balancer service. To do that, let's run kube control expose our deployment, and the name of the deployment is app deployment. In this namespace, the type of service we'll be using is load balancer. Okay, and the port is on port 80. Okay, I'll press enter, and this has been exposed. Okay, so we now have a service. Let's check the service that has been created for us. So get SVC now space. Okay, and this is app deployment service load balancer, and as you can see, the external IP we have here is the DNS name of a load balancer that was just provisioned for us. This is different from the one that will be provisioned when we deploy Ingress controller. I just want to show you that we can expose this service first of all and ensure that it is running before we go ahead to make use of our Ingress controller. So since this has been provisioned, I'll just copy this. Let's go and verify AWS, and let's go to load balancer section, and this is just the load balancer is the same. Okay, because this is AC7 and what I copied is also AC6. Okay, so it's the same load balancer. You can see automatically it was provisioned for us. So this is how load balancer type of service in a cluster works. The state is not showing active yet, but let's see if we can access the application in the browser already. Great, so this is it over here, and this shows that it is working. So if you're following this tutorial, I would like you to get your domain ready. Currently I have a domain name in Route 53, but you mustn't have yours in Route 53. No matter where or who your domain registrar is, you can actually use that for this project or for this tutorial. All right, so I have mine, and I'll quickly show you. You know, the load balancer, this DNS the DNS name is not basically what we give to our users. So for us to use a custom domain, I already have mine and Route 53, and let me quickly take you to Route 53 to just show you my custom domain. We're also making use of Certificate Manager for this. Okay, so I have my hosted zone or my custom domain ready, and in case you don't know how to go about you know, requesting for a domain name over here in AWS, or configuring the domain name, like to create CNAME record and request for your certificate, because we also have a certificate here. Don't worry, I'm going to be leaving a link because I've taught this in my previous video, so you can actually use that to get that done. I don't want to do this because it may take much of our time. So I have a certificate that's been issued to me, and I have a custom domain name. Please use that link in the description below to help yourself in case you don't have yours ready. Okay, so going back to my Route 53, so what I want to do is that I want to create a record, and I want us to use this custom domain name to access that. So let's create a record, and yeah, so I have 3 records here. This one is automatically, it was provisioned automatically after the custom domain name was was provisioned for me. I only created this CNAME record because I needed to validate my certificate, and yeah, my certificate has been issued to me. Now I want us to create an A record. Okay, so we can do the mapping. I want us to access our application using a custom domain name and not that load balancer DNS name. So for the record name, I'll leave this empty because I just want to make use of this. Okay, I'll just toggle on this. Over here, we are routing traffic to So we are choosing application and classic load balancer. Okay, and then the region is East US. Okay, US is here, and this is where we'll now paste the DNS. So I'll just copy the DNS name of our load balancer and paste it here. Okay, I need to get rid of this. Okay, and I'll choose that, and that's all I need to do. I'll click on create record. Okay, let's see. I'll click on view status, and once this says in sync, we'll go ahead and test with the custom domain name. It won't take time. I think this will basically be around 10 seconds or 15 seconds. So it is now in sync, and we are free to go ahead and make use of our custom domain name. I will copy this out and let's go. I don't know how quickly this can propagate, but let's see. Great, that works. Now that we've confirmed the application is running perfectly using our custom domain name, let's go ahead with deployment of our Ingress controller, Nginx Ingress controller. But before we do that, let's change this load balancer type to cluster IP. Okay, so because we won't be needing that anymore, the Ingress load balancer will be provisioned once we deploy that. So let's edit this. So keep control edit service, which is SVC, and the name of the service is app deployment. Okay, app deployment, and it is in app space. Okay, so I'll just locate where we have the type. I'll just get rid of the status of the load balancer. Okay, and I'll also, so here we have type of service as load balancer, so I'll just delete this and type cluster IP. Okay, and then I'm gonna save this. Okay, so if we check the service, you see that it is now cluster IP service. All right, so let's clear this and let's deploy our Ingress controller. So coming over here, I have the so this is the website for Ingress Nginx controller. So this is basically the installation guide, and coming to this right hand side, I can see under cloud deployment, this is AWS, and I'll click on AWS. Okay, so in AWS, we use a network load balancer to expose the Ingress Nginx controller behind the service of type load balancer. So this will basically provision a network load balancer. Right, so let's start by downloading the template. Okay, and I'll just grab this, I'll copy this command here. I'll go to my cluster and paste this here and press enter. Okay, so this has been downloaded as this is the name of the file. Okay, so let's check. If I run ls, this is the file here. Okay, so this is where the Ingress controller manifest file is. Now we can, before we go ahead to deploy, we need to make some modification in the file. So let's go into that. Okay, so once you open this file, come to line 329, right, and locate this proc0 IP CIDR. So this is where we'll be using our Kubernetes VPC CIDR. And how do we do that? I will just delete, or before deleting, let's go and see our VPC CIDR for our Kubernetes cluster, and that is what we need to replace here. So coming to EKS, I'll just click on my cluster and go straight to networking. I should see my VPC here. So this is VPC, and this is it here. So just copy this, go back and delete what I have here, then paste it. All right. It seems I have something here I need to get rid of. Okay. All right. And I'll go straight down again to this place. Okay, so under service here, you can see under kind service we have certificate, SSL certificate ARN. So we need to basically replace that with our certificate ARN. Okay, so I'll just get rid of the one we have here. So we need to go to our AWS Certificate Manager to get the ARN. Okay, so Certificate Manager, I'll click on this to open, and this is the ARN of our certificate. So now I can paste it here, and that is it. Okay, so this is all I need to do in this file, and the namespace that this file will deploy this controller in and some other component it will be deploying is Ingress Nginx. That is the namespace. So yeah, let's go ahead and save this, and then we can go ahead to deploy. So keep control create -f deploy.yaml, press enter. Okay, I think we're having this error because these services already exist. Okay, because I've actually deployed this before, and so let's first of all check our resources that just got deployed. But if this is your first time deploying this, you may not get this error because it is saying that this is already in existence here. So it is existing already, and but it actually created all these other resources. Okay, so let's get all in this namespace. Get all in Ingress Nginx, right? Okay, I can see that the bad job run to completion. The replica set is fine. The deployment of the Ingress Nginx controller is actually fine, no error. The Ingress Nginx controller admission also is fine. The Ingress Nginx controller load balancer, you can see it has actually provisioned a load balancer for us, and the type, it has provisioned a service, sorry, for us, and the type is load balancer. And you can see it provisioned a cloud load balancer for us. This is the external IP, so this is the DNS name of our load balancer. Okay, so this one is specifically for the Ingress controller, the Nginx Ingress controller. And yeah, so this is the pod that runs our Nginx Ingress controller, and it has no error. For these two pods here, it's completed. So this one completed already, and that is fine. Okay, because it's a bad job. So let me clear my screen. And what is the next thing we have to do here? We have to now go ahead to deploy our Ingress resource. So here I actually have Ingress resource we can make use of. Okay, so I'll just copy this and I'll explain. So if you remember, our application is running on app space, all right? So since our application and the service is running in app space, we have to deploy this also in app space. It doesn't matter where the ingress controller has been deployed to the namespace, but basically you need to ensure that your application and the ingress resource is running in the same namespace. All right, let's deploy this my ingress resource YAML. Okay, so I'll paste this. Okay, so this is an ingress resource manifest file. This will provision a Kubernetes object called ingress, and the name, you can change the name of your ingress to whatever you want. And over here we have the annotations. Okay, so this annotation is basically to the rewrite target, okay, of our ingress, and the part here is just give it /. So under spec here we are specifying the ingress class, and we are using Nginx as our class. For the rules here, this is basically where we'll now define the routing rule. How do we want the traffic to be routed in our cluster? Okay, so for the incoming traffic, let's define what we want here. For the host, this is basically the custom domain name. So I've given my techwithhelen.com, so you need to add your custom domain name here. So for the HTTP here is basically you specify that the rule handles HTTP traffic, all right? And for the path here, it defines the URL path for the routing. The path type is prefix. We'll leave it like this. The path I'll be using is just /, just leave it this way. And for the backend, remember, this can be configured depending on your application and actually what you want. Okay, so yeah, you can configure this depending on your requirements and all that, but the path to be using is this. For the backend, right, so this is where you define the back end, the service that you actually want the traffic to get to. The service we'll be using is the service that we used already to expose our application. Okay, and the name of the service is actually app deployment. You can go back to check the name of your service, but I remember ours is app deployment, and the ports of that service is port 80. Okay, let's not also forget to specify the namespace up here, so it has to be in the same namespace as our application. So namespace is app space, and that is fine. So this is basically what we need to do here. Ensure that you get the service name of your service correctly, ensure the port is correct, ensure your path, the host name is correct, and we are good to go. So let's save this and deploy. So keep control, apply -F, and this, and it has been created. So let's get this ingress in this namespace. You can see my ingress, the class is Nginx, host is techwithhelen.com. Let's describe it. Okay, so keep control, describe ingress in app space, and yeah, so this is the address. This is actually the address here is basically the DNS name of the load balancer that it provisioned, that the ingress controller provisioned. Okay, this is the class. For the rules here, we have techwithhelen.com, which is the domain name to access our application. For the path, this is it. For the backend, okay, this is interesting. So if you don't get to see this, that means something is wrong. Okay, so here it should have the IP address of the port that the traffic will be routed to. Locate the port with this with this IP address. Okay, so each of our pod, remember we have two replicas of our pod running, each of them has their own specific IP address. And if you check, if you run this command kubectl get pod -o wide in this namespace, you should be able to confirm that the IP is the same thing as what we have here. This IP address is the same thing as we have it here. So yeah, so that means we correctly configured this, and you can see the event. You can also see the annotation here. Okay, so everything actually looks nice. But before we go ahead into the verification, we need to go back to our Route 53 and change the A record, because we are using the load balancer that we used before to expose our application. All right, so we need to change that load balancer to what we have here. Let me take you to AWS and show you the new load balancer that we have. So after we remove the first load balancer type of service we use for deployment of our application, after we deploy Ingress Controller, a new network load balancer was provisioned for us. Okay, and let's see that this is it here, and it is, yeah, it's the same thing as the DNS name we saw in our cluster now. So if I click on this, it will show you that the load balancer type is network load balancer, which was automatically provisioned for us. So we have to go back to Route 53 and change the A record so that it can route traffic to this. All right, so copy. So how do you copy the DNS name? Just come here, copy the DNS name, and let's go back to Route 53. So what I need to do here is just to click on the A record. Okay, and I'll click on edit record. Where I'm interested in is just this place. So for the routing traffic, we need to change it to network load balancer, right? And the region is East US or US East. And then I will be pasting this load balancer here, and I'll click use. Okay, and that is it. I'll save it, and yeah, I'll click on view status, and let's watch this for the next 10 seconds or 15 seconds. And this is now in sync. Right now we can test our deployment to actually confirm that we can reach our application via the custom domain name, and yeah, also to validate that the deployment of our Nginx Ingress Controller is successful. Okay, so I'll just copy my domain name over here in Route 53, and let's go to the browser and test this. And this is it. It is successful. As you can see, it is making use of the certificate, meaning that this application is secured. This works no matter the type of application you want to deploy. Okay, just forget what you're seeing here. Okay, but it doesn't matter your application or whatever you want to deploy. This is actually very secured right now. Okay, and we can access it with our custom domain name, and we successfully deployed our Nginx Ingress Controller in AWS EKS. Now we've deployed this, what happens? Any user or client that try to access this application from the browser will make use of this custom domain name, and once you hit this, okay, immediately I typed or I pasted techwithhelen.com and press enter. Traffic was routed to our Nginx Ingress controller load balancer in AWS. And from the load balancer, the traffic was routed to our Nginx Ingress Controller in our cluster. Ingress Controller looked for the ingress resource we've defined, where we define our routing rules and all that, and he used that to locate the service, okay, where the traffic should be routed to. And after he located the service now located the pod. He routes the traffic to the pod, and the pod contains our application. That is why we can access this. And you can see the whole thing is just so fast. The whole routing is just very fast. Just enter the custom domain name, press enter, and you see the request has been returned back to you. It is just so fast to get from the load balancer provision by Ingress to the pod that run our application. And by using this Ingress controller in our cluster, we are streamlining our web traffic. We are making it both cost effective and flexible, so it adapts easily to changing visitors loads. Okay, so this efficient approach can benefit your organization by enhancing your application performance, reducing costs, and ensuring a smooth user experience. Okay, keep up the great work, keep learning. This knowledge is actually so beneficial. You can also use this knowledge to write your CKA, to write your CCAD, and because this question is sitting pretty well there and waiting for you. So be it your organization, you want to use it in your organization for deployment, production, or for clearing your exam, you're good to go. If you really enjoyed this video, please do well to give me a thumbs up to encourage me. This encourages me. It will make me know that okay, you are in support of what I'm doing and you want me to keep producing quality video for you guys. Okay, if you are yet to subscribe, do well to subscribe to my channel. It will only take you 5 seconds to subscribe. Click on notification bell. 5 seconds is even too much, so please subscribe and also share your comments. All right, comment, share your feedback, and also share this video with your friends within your circle. Thank you so much. I'll see you in my next video. Remember, you are the real MVP. Thank you so much, and bye.